Let's have a look at how to find the area of a triangle using trigonometry. We've got a triangle here. Let's look at the quick naming conventions. If you label the vertices of a triangle using uppercase letters, say A, B and C, then you need to label the sides with lowercase, and you use the same letter that is opposite that angle. So this one will be B. Over here we've got A and C. Now, so far you've always used this formula. Area equals half base height. That's half times the base times the height. Now, the problem with this is that if we call the base, let's say the base is this one, B, lowercase b, we'd actually need to know the vertical height, because the base and the height have to be at right angles to one another, don't they? We need to know the vertical height, let's call it h, to be able to use this formula. So what happens if we don't know h, but we do know something else? Well, let's use our trigonometry now to come up with an expression for h. Starting down here in this angle, if I said, all right, I've got this angle and I've got h and I've got another side, let's say a. Have a look at which trig ratio you need here. I have the opposite side and I have the hypotenuse. So I can write an expression for the sine of this angle C and say that it's equal to opposite, which is h, over hypotenuse, which is a. Now this works because when we drop this line down, see, this is a right angle, so this is a right angle triangle here. All right, to come up with an expression for h now, I really just need to rearrange this so that the h is all by itself. Now instead of having h divided by a, if I times both sides, multiply both sides by a, I'll have the h all on its own, and on this side I'll have a times sine c. So let's write that down. One side will be h, the other side will be a multiplied by sine c. Now make sure we use a lowercase a here and an uppercase c here. All right, how does this help us? Well, we now have an expression for h. We can now throw this into our old familiar formula for the area of a triangle. We've already got base and we can call that b. That's quite handy that this side is called b, and we'll just leave that like that. Now I can come up with, in fact, instead of writing a, because that's confusing, let's write area. All right, so now I can come up with a better formula for the area of triangle ABC, and that is half times the base, which is b, times h. Now h equals a times sine c. So I'm going to write that down. Now, before you start jotting this down and copying, I'm going to rearrange it. This is the letters that I used to find it. But if I'm writing BA, to me it seems kind of neater to write in alphabetical order. So at this point, I might just rub that out and put that's A times B. Does that seem fair enough? Now I've got my letters in alphabetical order. I've got half AB sine C. And that's something that's nice and easy to remember. It's just as easy as ABC. The only thing to take note of is that the A and the B are lowercase, so they're sides. And the C is uppercase, so it's an angle. So this is our new formula that we can use today to find the area of any triangle, half AB sine C. But we need to write down what those two things are. So let's put some detail where A and B are sides, and C is, now it's not just any angle, is it? If we look at where A and B are here, this angle C is special. It's not just any of the angles, it's the included angle, which means that between the two sides that you have, you need to have the angle that sits right between them. So where C is the included angle. Now, obviously you could write this formula down three different ways. If you were talking about the area being half BC, and you'd use the sides B and C, what would the included angle be then? It would be A, wouldn't it? So you could write it half BC sine A. You could also say it's half, what are the other two we haven't used? AC. And if you'd used A and C, the included angle would be B. So these are perfectly good alternative formulas. Which one do you need? Well, I think it's confusing to try and memorise three. I would stick with this one because it's got the A and the B and then the C, but you really need to be clear on the fact that C is the included angle between the two. Now you'll see why when we go to do an example. Let's make sure we get this down. Probably don't need to write down these other two, but just understand what they mean. Let's go ahead and do an example to see how this works. Now, they'll often give you a red herring in a question like this. Let's say we've got a triangle and we have, let's call this 60 degrees, and this could be 25 degrees, say. And we might know that this is, let's say, 10 centimetres. It's not to scale, obviously. Now, you need to work out which bits of information you can use to find the area. You've got two sides. So do you need this angle or this angle? You need to make sure you're using the right angle, and often they'll give you more information than you need to check if you can pick out the right bit of information to use. So to find the area of this triangle, area equals, start by writing the formula out. If you write it every single time, after a while you just know it. So I'm going to say half AB sine C, right? Now write it down that way even if you don't have A's and B's and C's on your picture, because once you look at that, it'll just remind you, oh yeah, I need two sides and an included angle. Now you can say, what two sides am I going to use? 10 and 9. So I've got half times 10 times 9 times the sine of 25 degrees. At that point, reach for your calculator, and we have half times 10 times 9 times the sine of 25, and it gives me 19.01. And then if it hasn't specified how to round it off, then take your pick. I'm going to round it off to 2 decimal places here, and then I'm going to write to 2 decimal places. Now, think back to the picture and think, would this be about right? If this was 9, this was 10, what would the area? Remember finding how much space is in here. As soon as you relate it back to the picture, it's going to remind you that you're missing something here. Not only how to round off, but you need some units, right? Now, it probably would make sense to write that a little bit further along to 2 decimal places. So I've got room for my units here. And because we're doing area, we need centimetres squared. And that's how you find the area of a triangle using trig.